Good evening, class. We are looking at college algebra practice test, which is part of the final exam, module 5, chapter 9 review. Chapter 9 is about sequences and series. So I want to make sure that we understand that. And of course, as always, the pledge, and I can't emphasize this enough. I'm assuming everybody is taking the exam on their own. You may use a scientific calculator for the entire exam, and some of the questions you may use a graphing calculator. All right, find the infinite sum if it exists for this geometric series, -2 plus 0.5 plus negative 0.125 and so on. So geometric sequence, reminding you, recursively is defined as a sub n plus 1 is r a sub n. Explicitly, a sub n equals a sub 1 r to the power of n minus 1. And the first n terms, they add up to a sub 1 times 1 minus r to the power of n over 1 minus r. Now, if r happen to be between -1 and 1, this goes to 0 as n becomes larger and larger, as n goes to infinity, s sub infinity, or limit of this piece as n goes to infinity. So all we have to do is to look at the first term and find the r. If r by any chance is between -1 and 1, we can use the easy formula. Otherwise, it doesn't work out. So having said that, a sub 1 obviously is -2. What is r? Divide this one by this one by this one, and you find it to be -1/4. It's a good practice. After you divide this one by this one, you try this one by this one also, just to be on the safe side. However, they have given us a geometric series. If they said, okay, check it out to see if it's a geometric series, you have to check it further. Obviously, this is between -1 and 1, which means I can use this formula. So I'm going to replace the a sub 1 with -2 and r with -1/4. So I get -2 over, so s sub infinity equals -2 over 1 minus -1/4. Obviously, minus and minus is plus, so they add up to 5/4. And okay, so you multiply these two, this is 1. Multiply these two, we get -8/5. So it's very straightforward, everybody. Okay, very straightforward. And I hope everybody's okay with that. We want to find the infinite sum in this case, and of course, we had looked at this previously. If you plug in k equals 1, this becomes 0 and this becomes 1, so it's 9. If you plug in 2 becomes 1, 1/4 times 9 is 9/4. So therefore, it is a geometric sequence. The sum is a geometric series with the first term being 9, and r is 1/4, or simply you can divide 9/4 by 9. And because, again, r is between -1 and 1, we can use s sub infinity is a sub 1 over 1 minus r. So plug in, replace the a sub 1 with 9 and r with 1/4. And again, in some texts, they may use a, by the way. And so 1 minus 1/4 is 3/4, and 9 over 3/4 is 12, everybody. You can write it as 9 over 1, and then you multiply 9 by 4, you get 36, divided by the product of these two, 3, and you get 12. So it's pretty straightforward, everybody. We are going to move on. All right, let's see what happens here. On each swing, left to right or right to left, okay, a pendulum travels 90% as far as on its previous swing. If the first swing is 10 feet, determine the total distance traveled by the pendulum before coming to a complete stop. Well, we start with 10, and then each time we get the 90%. For example, initially is 10, then it becomes 90% of it, which is 9. So that represents a geometric sequence. We're going to add them up to a geometric series. The first term is obviously 10, and 90% represents R. Now, R is between -1 and 1. Therefore, we can use S sub infinity is A sub 1 over 1 minus R, which means replace the A sub 1 with 10. 1 minus R is 1 minus 0.9. This becomes 0.1. And 10 divided by 0.1, that means 10 times 10 is equal to 100 feet. So that's pretty straightforward, everybody. A ladder consists of 31 rungs if the rungs taper uniformly from 18 to 28 inches. How much material would be needed for the 20th rung? So the idea is that the ladder, which looks like that, so the top one is a little bit smaller than the bottom one, but they are uniformly set. Therefore, the smallest one is 18, the largest one is 28, which means 18, we add a little bit to get to the next one, same amount to get to the next one, and the next one, and next one. Therefore, you're dealing with an arithmetic sequence. 31 represents N. 18 represents A sub 1, the first one. And 28 represents A sub N. N again happened to be 31. So we want A sub 20. So this is explanation of the question. In other words, reading and translating. So one more time. This uniformly explains that the width gets larger from the beginning, which is 8, by the same amount. That's the meaning of that, which makes it into an arithmetic sequence. And so again, reminding you of that, so we can say A sub n is A sub 1 plus n minus 1 times d. We use that to find A sub 1 is given to find the missing d, because an arithmetic sequence is known as long as we have two things, the first term and the d. So we know that A sub 31 is 28. So we're going to write A sub 31. A sub 31 is A sub 1 plus 31 minus 1 times d, and A sub 1 is replaced by 18. So A sub 31, n is 31, is A sub 1 plus n minus 1 times d. We replace the A sub 1 with 18 and n with 31. 31 minus 1 is 30. So we subtract 18 from 28. We get 10, divide, and D becomes 1/3. Of course, the units, inches. All right, now, so we have the A sub 1 and we have the D, so we can find any term. More specifically, we are interested in finding A sub 20, which is A sub 20 is A sub 1 plus 20 minus 1 times D. And just plug in, replace the A sub 1 with 18, 20 minus 1 times D with 1/3. I hope you see if it was 18 would be 6 and 18 is 24, so 24 and 1/3. This is an easy way to add them up in this manner. Again, 18 divided by 3 is 6 and 8 is 24, but this is 19, so it gives you an extra 1/3. How much material would be needed for all of the 31 rounds? That means we want S sub n, and we can use any of those formulas. What happens is that we have the first term and the last term, so we're going to take the easy way out, n over 2 times A sub 1 plus A sub n. So n over 2, n is 31, because this is S sub 31. And the first one is 18, and the last one is 28. 18 and 28, 46. Or the 6 divided by 2 is 23 times 31 is 713. And the units, same units, inches. A quick recap, class. I want to make sure everybody is following that. It's very straightforward. We have 31 rounds, and it tapers uniformly from 18 to 20. So the smallest one is 18 inch, and the largest one is 28 inch wide. And because they are going uniformly, that means we are adding a little bit to each one. And that amount is the distance or difference, which is common. The given information by writing n is 31, A1 is 18, A31 is 28, A sub 20 is missing. We can go through the process, find the D. When A1 and D are given, everything else can be evaluated easily, and the same thing for S sub n, which is the sum. All of those, we have to add them up. So in one shot, we can use this formula and add them up. All right, let me remind you of the factorial symbol and binomial theorem. If n is larger than or equal to 0, and it's an integer, the factorial symbol, n factorial, is defined as follows. 0 factor is 1, 1 factor is 1, n factor is n times n minus 1, n minus 2, all the way times 3 times 2 times 1, and n is larger than or equal to 2. So just for the sake of argument, so if I said, okay, what is 5 factorial? It just means 5 times 4 times 3 times 2 times. That's the meaning. And so with that being in mind, n factorial is the same as n times n minus factorial. You can stop anywhere you want and put a factorial. For example, if you have 12 factorial and 10 factorial, because 12 is larger than 10, you're going to keep the bottom as 10 factorial. And the top, you're going to write 12 times 11. Instead of going all the way down, we stop at 10 factorial because we can drop it. And so the answer is 12 times 11, which is 130. So this is a fairly easy way of doing it without using a calculator, okay? Combination of n elements taken R at a time. A subset of items selected without regard to order is called a combination. A combination of n elements taken R at a time with R less than or equal to n is denoted by, there are 3 ways to write it, CNR Parentheses NR represents a pair as well as combination or CNR. And it's sometimes read as N choose R. The formula N factorial over R factorial times N minus R factorial. This is the formula for a combination. Note, order within the group of R objects is not important. Okay. So how many different combinations of 3 people can be chosen from a group of 8 people? And that's exactly what's happening. We just want 3 people. In what order? It's not important. A committee is an unordered set, the arrangement of people. Therefore, order is not important. And that's important to understand. You use combination. So C83, and that would be, according to this, 8 factorial over 3 factorial, N minus R, 8 minus 3, 5 factorial. Now, how do we simplify it? You can do it by hand in the following manner. Notice 8, of course, is the largest. At the bottom, 5 is larger than 3. So you keep the 5 factorial. And so you can write this 8, 7, 6, 5 factorial. 3 factorial, you have to expand it to 3 times 2 times 1. Then these two cancel each other. And 6 is the product of 3 times 2. So the denominator is just 1. So 8 times 7, 56. My point is, you can easily come up with the answer, okay? That is the idea. Now, for larger numbers, you can use a calculator, okay? So for a TI calculator, permutation, combination, okay? Enter the value of N first, and then press math, select PRB, select NPR or NCR. This is permutation. This is combination. Enter the value of R, enter. So, for example, here, we can see that right here, when we go to press math and over here, down here, the third one is a combination. The one before that, NPR, is the permutation. So 8 NCR 3 is 56. So NR, CNR, parentheses, N at top of R, N factorial over R factorial, N minus R factorial. These are different ways of writing the same thing. So that is the combination, everybody. So we chose 3 people from 8. Now assume 8 people enter a swim competition. In how many ways could the gold, silver, and bronze prizes be awarded? Now, it's not just we choose any 3. Order is important, because the first one gets the gold, the second one silver, the third one bronze. So order becomes important. That's the difference. And permutation. So a permutation of n elements taken R at a time is one of the arrangements of R elements from a set of n elements. If P n R or P n R in this format denotes the number of permutation of n elements taken R at a time with R less than or equal to n, then P n R is n factorial over n minus R factorial. If you recall, the combination has another R factorial. In other words, R combination is larger, okay? And so order within the group of our object is important. That's the key. Notice there's a permutation of 8 people taken 3 at a time. Order within the group is important. So permutation 8, choose 3. So according to this formula, 8 factorial over 8 minus 3 factorial, which means 8 factorial over 5 factorial. Now, I want to show you both ways. Of course, you know, I'm not going to do the first way. The first way is just expand. But the second way, as I said, this is 5 factorial. Keep it so it becomes 876 times 5 factorial. I would go this route. That is the meaning of it. That's easier. So we drop the 5 factorial. So it's 8 times 7 times 6, 336. Again, we've already discussed that. You use either NPR or NCR. Okay, so math, remember the second one was NPR, the third one is NCR. So you put 8 NPR3 and it gives you the same answer as expected. So that's the idea of a permutation versus combination. In the case of a permutation, we have the case that order matters and combination order doesn't. If you recall, combination was only 56. Permutation is a lot more because order is important. For example, if you're choosing a password, order is important. Okay. The binomial theorem. X plus a to the power of n is the summation r going from 0 to n of c and r x to the power of n minus r a to the power of r. This is a combination n factor, so summation r going from 0 to n, r factorial n minus r factorial, n factorial over r factorial times n minus r factorial. This is the combination x to the power of n minus r a to the power of, which means the first one is n0 x to the power of n a0. And I want you to pay attention to this one. We start with n0. Look at just the coefficients, then n1 all the way to nn. Exponents. The first one takes the exponent n, the last one takes the exponent 0. The sum must be n. The sum must be n. So as we go down to the next one, this becomes 1. N goes down by 1, and this is 1. And all the way to the last one, nn, x to the power of 0, a to the power of n. Needless to say, and we will look at that. What happens that this is 1, so is this one. Really, the first term is x to the power of n. This is 1, this is 1, so this is just a to the power of n. Okay, I'm going to get to that. A couple of those that we have seen in algebra. A plus b squared is a squared plus 2ab plus b squared. A plus b cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed. That's another one. I hope you remember those. They come from this. Now, of course, if the exponent is larger, then this is how you do the expansion. So, as I mentioned, n0 and nn, they are 1. n1 is n, nr is n with n minus. I want to quickly, look at a couple of them. For example, if I look at the first one, I suggest you guys do that. N0 is what? N factorial over 0 factorial, n minus 0 factorial. And I hope you see that the numerator is n factorial, so is the bottom, and the answer is 1. So I leave this one for you to show. Okay. This one, n1, is n factorial over 1 factorial times n minus 1 factorial. So the bottom is n minus 1 factorial. The numerator is n times n minus 1 factorial. So the answer is n. And what I want you to see for this one, and I leave it for you to do, these two numbers, they add up to n. Okay? R and n minus r, they must add up to n. For example, let me just erase the board. If I have 8, 3 here, what number should I put here? 8 minus 3, 5. These two must be identical, and you can check them. Okay? Just to give you an idea. So, and it's good to know, it will speed up the process as you go through a binomial theorem expansion. We want to use the binomial theorem to expand 3y plus 2 to the power of 4. And again, reminding you of this, okay, x plus y to the power of n, or just as I put it in the previous page, it was x plus a. It doesn't matter, okay? The second one is a number, such as this one, or it's a variable. You just follow this methodology and you come up with the answer, okay? So going with the expansion. So And I want to write the combination. So n is 4. So we start with 4, 0, the first one to the power of 4. Okay. And the next one, I don't write it because it becomes 1. 4, 1, 3y cubed, 2 to the power of 1. 4, 2, 3y quantity squared, 2 squared. 4, 3, 3y times 2 cubed, 4, 4, 2 to the power 4. This is just following the expansion. One thing I want to make a point of, sometimes students make the following mistake, and they don't come up with the answer. Instead of writing this, they write 3y to the power 4, which is wrong. In other words, they do not raise number 3 to the power of 4, and that is a problem, everybody. So let's just erase this. We know this is 1. We know this is 1. Okay. We know 4, 1 and 4, 3 are the same. Okay. And remember, this was n 4. So this is the same. Again, why is that? Remember what I told you. If n is 4, these two can add up to n. They're identical. So you don't have to do anything except let's calculate for 2, which is 4 factorial over 2 factorial times 4 minus 2 factorial. So this is 4 factorial over 2 factorial times 2 factorial. And I hope you see that this one is 4 times 3 times 2. And this is 2 times 2, 4. Okay. 2 factorial is 2. So the answer is 6. So let's replace what we have to. So we said this is 1. This one, 3 to the power of 4, which is 81 y to the power of 4. This is 4 times 2 times 3 cubed, which is 27 y cubed. For 2, we ended up with 6. 6 times 2 squared is 4 times 9y squared. 4, 3 is 4. Okay. Times 3y times 2 cubed is 8. And this is 1. This is 2 to the power of 4, or 60. I hope everybody can see that. So 3y plus 2 to the power of 4 is this one, 81y to the power of 4. 4 times 2, 8 times 27, 216y cubed. 6 times 4 times 9, 216y squared. 4 times 8 times 396. Y plus 16. We're done. One thing I want to make a point of, because there is a coefficient in front of y, and because this number is not 1, you want to really be careful when you raise them to the power. You raise the entire thing to the power. So they give you something they want you to expand, you follow that. Find the 7th term in this expansion, y plus 3 to the power of n. There are several ways. Number 1, just expand the entire thing. Never mind what they said. Okay? One way to do it, just expand it without paying any attention to this one. Then read the question and say, okay, which one do we want? The 7th term. So start counting. 1, 2, 3, 4, 5, 6, 7. Oh, this is the 7th. That's one way to do it. But there are other ways to look at it. Okay. And I'm going to look at that. The rth term of the binomial expansion, x plus y to the power of n, is summation of r going from 0 to n. That means n r x to the power of n minus r y to the power of n. Okay, so we already know that, and this one is n factorial over r factorial times n minus r factorial. The rth term of the binomial expansion of x plus y to the power of n, where n is larger than r minus 1, you can go with n r minus 1, x to the power of n minus the parenthesis r minus 1 and y to the power of r minus 1. Or the term containing x to the power of j is n minus j, x to the power of j, y to the power of n minus j. C and r is this. Or never mind any of those formula. Let me tell you how to achieve that. Number 1, everybody agrees that n is 8. 7th term Okay. R is 7. X is y and y is 3. If we look at this one. Okay, so we want to find the seventh term. Okay. So n r minus 1, x to the power of n minus r minus 1, y to the power of r minus 1. I'm going to go through that, but then I'll show you even an easier way. So replace them. Replace the n with 8 and r with 7. And work it out. Okay. But here's the method that may make it easier. As I mentioned, you don't have to memorize any of this. You can instead expand it and count 1, 2, 3, 4, 5 and find the second. Or x plus y to the power of n. Write this one. So we're going to write y plus 3 to the power of 8 is the summation r going from 0 to 8, 8 factorial over r factorial, 8 minus r factorial, x to the power of n minus r becomes 8 minus r, 3 to the power of r. So let's write this. So this is just this expansion we're supposed to do. So recognition of what you need to do. If I want the very first term, r must be 0, right? If I want the second term, r must be 1. If I want the third term, r must be 2. Therefore, the seventh term, r must be 6 with this one. So this is the fastest and easiest way to understand it. Write the expansion and think about it. If I want the first term, r is 0. If I want the second term, r is 1. So the seventh term, r must be 6. That's where this r minus 1 comes from, instead of memorizing it just with this. So right now, we are going to replace the r with 6. So it's this. When r is 6, that means 8, 6, combination of 8, 6. Y to the power of 8 minus 6, 3 to the power of 6. That would be the seventh term. 8, 6. Y to the power of 8 minus 6, 3 to the power of 6. So this is 8 factorial over 6 factorial times 2 factorial. This is y squared, and this is 3 to the power of 6. This one, class, we're going to write it as 8 times 7 times 6 factorial. 3 to the power of 6, 729. We're going to drop the common factor of 6 factorial. 2 factorial is 2. 2 factorial class is 2 times 1 is 2. We drop it, and we change this one to 4. And we get 4 times 729 y squared. We get 20,412 y squared.